Dear students, now we will going to have a discussion on the question bank session, that is session 27 of chemistry paper 5 in the 5th semester syllabus of Kuvempu University. This is the unit 2 of inorganic chemistry, and that is chapter 2, alloys. In this question bank session, we will going to discuss on multiple choice questions and few 1, 2, 3, 4 and 5 marks questions as well. In our previous sessions, we had a discussion on the preparation of alloys by electrodeposition and powder metallurgy methods, and advantages of powder metallurgy, influences of various elements on the properties of steel, and heat treatment of steel, and different processes in the heat treatment like hardening, tempering, annealing, case hardening, etc. Now, the learning objective of the present session is to select a suitable answer for the respective multiple choice questions and to know the answers for 1, 2, 3, 4 and 5 marks questions. The outcome of the present session is one can select the suitable answer for the respective multiple choice questions, and one can able to answer for 1, 2, 3, 4 and 5 marks questions in this session corresponding to this chapter. Now coming to a few multiple choice questions which carries 1 mark each. So the first question is, in the electrodeposition of alloys, the source of current used is dash. Options are AC, DC, solar and none of the above. In this process, actually the DC current is used. It is to maintain a permanent polarity of cathode and anode. So option is DC. And the second question is, the powder metallurgy is carried out dash the melting point of the alloy to be prepared, and the options are below, above, at the same and at any temperature than. So the correct answer is below the melting point of the alloy, because at this particular temperature the sintering of the particular alloy occurs. And the third question is, complex shape can be formed effectively using dash, by using powder metallurgy, by using turning, by using sand casting, by using metal casting. And the correct answer is powder metallurgy. It is because the whole process can be in control, it can be controlled, so therefore you can prepare the required shape of the metal using powder metallurgy. So the option is powder metallurgy. And the fourth question is, complex shaped materials can be achieved by using electroplating, powder metallurgy, hydrometallurgy and pyrometallurgy. And the option, as we have discussed above in the third question, the answer is powder metallurgy. And coming to the fifth question, dash increases the elastic limit of nickel, and the answer is elastic limit of steel. The options are nickel, silicon, carbon and cobalt, and the correct answer is nickel. It is because it reduces the ductility and increases the elastic limit. So nickel is the correct answer. And the sixth question, dash increases the magnetic properties of steel. The options are carbon, nickel, tungsten and silicon. The correct answer is silicon, because it increases the magnetic flux through the metal. So therefore the magnetic property enhances. And coming to one more question, the first question, define electroplating. It is actually the deposition of any particular metal on the surface of cathode by the passage of electric current. Or with respect to the electrodeposition of you know the required metal, and in particularly metallurgy, coming to the metallurgy, the electrodeposition is actually the simultaneous deposition of alloying compounds is done on the mold of desired shape, which is made as cathode by the passage of DC current. So deposition of an alloy on the mold of desired shape, which is made as cathode by the passage of DC current. So that is with respect to alloys. And the second question, what is meant by powder metallurgy? The answer is powder metallurgy deals with the production of metal powder and mixing them with the other metal powders, and the mixture is subjected to high pressure to get a solid mass. So a solid mass is obtained by mixing a metal powder with the other metal powder and subjected to high pressure in the powder metallurgy. The third question is define annealing of steel. It is actually a heat treatment process. That is, annealing is a heat treatment process which is performed primarily for homogenization, recrystallization, or release of strength in typical cold worked components. So annealing is a heat treatment process to um, you know increase homogenization, recrystallization, and it reduces the stress in the steel. And two marks questions. The first question is, give a brief account of influence of chromium on the properties of steel. You know that chromium is an important metal which influences the properties of steel. It strongly increases the hardenability of steel. It improves the corrosion resistance, and its presence may cause excessive hardness and cracking in and adjacent to welds. So usually it is used to increase the hardenability, to increase the corrosion resistance in the steel. Okay. Now coming to the second question, why case hardening is needed in metallurgy? Case hardening is actually a simple process of hardening of surface of metal object. That means it is not to the core, it is only hardening of the surface of metal object. In this process, the surface of metal object becomes hard and the core of the metal object becomes soft. Okay, so case hardening is a process in which the surface of metal becomes hard and the core of the metal becomes or metal remains soft. It is also known as surface hardening. In this process, a thin layer of harder metal is formed at the surface. So in this process, a thin layer of harder metal is formed at the surface of the metal object. So this is the answer for the second question. And coming to the 3 marks questions, the first question is, explain the tempering of steel. It is an important question. So tempering is actually achieved by heating hardened steel to a temperature below certain temperature, which is in the range of 100 to 680 degrees centigrade. So heating the hardened steel below a certain temperature in the range of 100 to 680 degrees centigrade, and hold the component at this temperature for a soaking period of 1 to 2 hours and subsequently cooling back to the room temperature. So what we have to do? We have to heat the steel below certain temperature within the range of 100 to 680 and hold the component at this temperature for a soaking period of 1 to 2 hours and subsequently cooling back to room temperature. Okay, so this is actually the tempering. The tempering temperature is decided based on the type of steel. Highly alloyed tool steels are tempered in the range of 500 to 600 degrees centigrade. And tempering is used on hardened steel to reduce its brittleness. So the brittleness of the steel can be reduced by using hardening within the range of temperature 500 to 600 degrees centigrade. Okay, hope you understood the answer for this question. And coming to the second question, what are the advantages of powder metallurgy? Usually this type of questions are asked in the examination, and it is also an important question. So the answer is, important advantage is there is an unlimited choice of alloys, composites, and associated properties in the powder metallurgy. So we have a wide range of choice for the preparation of alloys, composites, and their associated properties. And refractory materials and metals, non-metals can be mixed in this process in any proportions. The second advantage is refractory materials and metals, non-metals can be mixed in any proportions in this method. And it is actually very economical at large run sizes. It is important. Okay, so it is economical and long-term reliability through close control of dimensions and physical properties. So there is a control over the dimensions and physical properties, and wide latitude of shape, design, and complex shapes can be obtained. So complex shapes can also be achieved by this process. And another advantage is very good material utilization, cleaner, and quieter operation. So these are some of the advantages of powder metallurgy. Okay, so next coming to the 4 marks question. Explain the preparation of alloys by electroplating method. So the first question is explain the preparation of alloys by electroplating method. So what we have to do to get an alloy by electroplating method? In this method, simultaneous deposition of alloying compounds is done on the mold of desired shape, which is made as cathode, and a DC current is used as a current source, and the electrolytic solution of metal salt which are to be alloyed are used in the cell. Means the metal which is to be deposited is taken in the form of an electrolyte, and in this method a good quality of alloy is obtained. So the experimental setup consists of a cell which is having an electrolyte consisting of a metal to be deposited, okay, and a cathode. Cathode is of required shape which is in the form of mold, and anode. Usually anode is having a metal which is similar to the metal which is to be deposited, and the cell is connected to an external DC power supply through voltmeter, ammeter, and a rheostat. And the cell is closed with a bakelite holder. So this is the experimental setup. Okay, hope you understood the answer. What we have to do in the electroplating method, here simultaneous deposition of alloying compounds is done on the mold of desired shape, which is made as cathode by the passage of an electric current, that is DC current, and metal to be deposited is taken in the electrolyte, and a cathode and anode are dipped in the electrolytic solution, and it is connected to the external circuit having a DC power source, and which is connected to a voltmeter and an ammeter through the rheostat. Okay, so this is how you can carry out the electroplating of an alloy. And the second question is write a note on heat treatment of steel. Heat treatment is a very important process in the metallurgy, that is in the preparation of alloys. The heat treatment of steel includes heating and cooling operations or sequence of two or more such operations applied in order to modify its metallurgical structure and alter its physical, mechanical, and chemical properties. So, heat treatment is done to modify the metallurgical structure and alter its physical, mechanical, and chemical properties. Okay, so usually heat treatment consists of heating the material to some specific temperature and holding at this temperature for a definite period of cooling, and cooling to the room temperature or below with a definite rate. So what we have to do in the heat treatment? Heat treatment consists of heating the material to some specific temperature, holding at this temperature for a definite period of time, and cooling to room temperature or below with a definite rate. So usually heat treatment are done by the annealing, normalizing, hardening, and tempering. These are the four widely used heat treatment processes. So this is the answer for the second question, that is the write a note on heat treatment of steel. And the third question is discuss the carburizing and nitriding of steel. So what is carburizing? Carburizing is a process in which steel absorbs carbon while metal is heated in the presence of carbon bearing material like charcoal or carbon monoxide. So carburizing is a process in which steel absorbs carbon while the metal is heated in the presence of carbon bearing material like charcoal or carbon monoxide. Carburizing is also referred to as case hardening, which is a heat treatment process to produce a surface resistant to wear while maintaining toughness and strength of the core. So after carburizing, what happens? After carburizing, the work is either slow cooled for later quench hardening or quenched directly into oil. So this is about the carburizing process. Next, let us see what is nitriding. Nitriding is also a heat treatment process that diffuses the nitrogen into the surface of a metal to create case hardened surface. That means the only surface become hardened but core remains cold. Okay, so in the nitriding, the diffusion of nitrogen takes place at relatively low temperatures near to 524 degrees centigrade. At this temperature, what happens? When nitrogen is diffused into the base steel, the hardening of steel occurs without quenching of the surface. Okay, so this is about the nitriding process in the heat treatment of steel. Okay, so coming to the last part of the question bank session, that is a 5 marks question. Here we will have a question that is discuss the preparation of alloys by powder metallurgy method. So already we have discussed about the powder metallurgy. So let us see what is powder metallurgy first. Powder metallurgy deals with the production of metal powder and mixing them with the other metal powders, and the mixture is subjected to high pressure to get a solid mass. So powder metallurgy deals with the production of powder metal and mixing them with the other powder metal, okay, or metal powders, and the mixture is subjected to very high pressure to get a solid mass. This you have to write. Okay, then the operation is carried out below the melting point of alloy to be prepared. That is, the powder metallurgy is carried out below the melting point of the alloy to be prepared, because at the temperature below the melting point of alloy, the sintering of the elements occur properly. So therefore it is carried out below the melting point of the alloy. During the reaction, what happens? The tiny metal particles diffuses towards each other and get welded to form an alloy. So during application of high pressure on the mixture, what happens? The tiny metal particles diffuse towards each other and get welded to form an alloy. So in the powder metallurgy, the complex shaped materials can be obtained easily, because the powder metallurgy process is controlled. So every step can be easily controlled. So therefore complex shaped materials can be obtained. And the powder metallurgy involves the following steps. The number one, powder production. Second, blending or mixing. Third is powder compaction. Fourth is sintering. And finally, finishing. So the steps involved are powder production, blending, powder compaction, sintering, and finishing. So these are all the things you have to write down, and you have to draw a diagram showing the experimental setup. So what does it consists of? So it consists of two dies. One is the lower die and the other is upper die. In the lower die you will have a molding cavity in which the powder is taken, metal powder or mixture of metal powders is taken, and the lower and upper dies are held together by guide pins. And when we take a mixture of metals in the molding cavity of the lower die, and a high pressure is applied from the upper die, and after obtaining the required alloy, it is extracted from the lower die through an extraction pin. Okay, so the instrument consists of lower die and upper die, which are held together by a guide pin, and the lower die consists of the molding cavity in which the mixture of metals is taken, or powder mix of the metal mixture is taken, and a high pressure from the upper die is applied on the lower die or the material taken in the molding cavity. After obtaining the alloy, it is extracted from the extraction pin of the lower die. So this is about the process of preparation of alloy by powder metallurgy process. Hope you got the satisfactory answers for all the questions. That is multiple choice questions, 1 marks, 2 marks, 3 marks, 4 marks, 5 marks questions. Okay, so you can go through these some textbooks, that is Principles of Inorganic Chemistry by Puri Sharma and Kalia, Advanced Inorganic Chemistry by Cotton and Wilkinson, Textbook of Industrial Chemistry by B.K. Sharma, and Modern Aspects of Inorganic Chemistry by H.J. Emilius and A.J. Sharp. So thank you very much for watching this video.